Good morning everyone. Now going to topic the electron transport. Electron transport. Then the electrons is almost all, that is the during of the electron is completely formations of defined, that is here it is the complex type of the electrons. That means the complex type means cytochrome, and already we discussed that is the study about light harvesting complex. Then the cytochrome A, cytochrome B, cytochrome B6, cytochrome F, plastoquinone. These are the completely one kind of the complex systems. So then the electron transport is also moving to the transport that the electron, it takes place in the citric the type of the mitochondria. It takes place in completely citrate mitochondria. It takes place mitochondria. Then the almost of electron transport it complete, then the final stage of it has in the every kind of then the aerobic respiration. Then here most of then mitochondrial that has complex type of complexes, that means glycolysis of then the complexes. Okay, then most of it has in the glycolysis complex, it carries to the that means ubiquinone or cytochromes, that is the cytochrome defined of the C, cytochrome C. Then the cytochrome C, it is almost all cytochromes A, cytochrome C, that means these are the different type of the complexes, the ubiquinone or cytochrome complex. Cytochrome complex, cytochrome A or B or B6, F, ubiquinone, plastocyanine. This one of the complex system. Okay, then this one of the complex system. Then it almost all of in the complex system, it is the multi-complex type of the system. Then it has in the understand about that is the complex. Then each of that has in the complexes is convert into the then the define of the compositions, that is the components of complex. Then components of complex, that is the stages it has in the 1 2 3 4 some kind of 1 to almost all 3 stages is defined. Then again the 4th to 5th stages is also one differentiations of the stages. Then the cytochromes to plastocyanine is also one variations of the cycle. Then this almost all the define of variation or variety of the cycles. Then the most of cycles is utilized in the that has mostly it has in the mostly it has in, that means the complex of cytochrome, that is the enzymes. It is the flavin or define of the plastocyanine kind of the enzymes. So in this process almost all it has in the 3 variations of the cycles, that is the mitochondrial matrix, inner membrane, and that is the perimitochondrial space or outer membrane. So in this almost all it has in the 3 ways of then the cycle. So for example it has in the 3 ways, that is the then then it gives to the define of the cycle, that is the mitochondrial matrix. Then inner membrane, then that is the perimitochondrial space or outer membrane. Perimitochondrial or outer membrane. So this complete then the reaction, it has going to define of then the reactions almost all. So here mostly it has complex 1 and complex 2 and complex 3, complex 4. Then almost all, it first of all it gives to the mitochondrial membrane, it gives to completely, then the production of the inner membrane, it gives to Fm, then N, then Fmn is gives to completely then ubiquinone, that is the formation in ubiquinone. Fmn is presence of in the ubiquinone. Then the ubiquinone almost all here the NADH plus H plus molecule, it completely then the NAD plus NAD, then most of it has given to the Fmn. Then here it is the succinylase, then almost it gives to fumarate. This one is the complex 2. Then this is the complex 1. Here almost all of the enzymes is going to the define of the 4H plus atoms. Then it mostly given, that is the succinate is present to the FAD, it gives to ubiquinone. Okay, then the again complex 2, then the most of it has in the 4 molecules of electrons, then 4 molecules of the protons, then gives to again define. Then here is the complex 2, it gives to the cytochrome B and cytochrome C. So these are the 2 are also different. Then it gives to the completely fumarate enzyme. Then cytochrome C is gives to again cytochrome C molecule. Then it again then the cytochrome. Then it most of it has in the cytochrome A. Then cytochrome A. Then most of it has in the 2 protons. It is the complex 4. Then almost all it has in the complex 2, complex 1, complex 2, complex 3, complex 4. Then most of it utilized in that has the H2O, it is split out into the half molecule of oxygen plus 2 molecules of H. Then it is converted to the H2O. It's again completely ADP plus inorganic phosphate. It gives to the ATP. Then most of 2H is synthesized in the complex 5, then it gives to the F1 and it product of H plus, then F0, then again F0. Then the matrix of H plus molecules is conversion. Then the stages of define of that kind of the stages. That is almost all of the electron transport. Then the 4H plus 4H protons, then again 2H protons is conversion. Then here also then the H plus proton. Then almost all it has it given to the electron. Then the fumaric acid, it completely then the FAD and ubiquinol. These are complete into complications of then the formation of FMN. This FMN is present in that is the inner membrane. Okay, that is the inner membrane. Then it most of it has in the mitochondrial membrane. Then mitochondrial membrane is producing the NADH plus, then H plus. Then it is the presence of the NAD plus. So mostly it is used in the succinate enzyme. Then the convert of the succinate, it is also in the fumarate enzyme. This one is the complex 2. Then almost all of the cytochrome B, then cytochrome C, it is in the complex 2. Then the complex 2 again it is complex 1, complex 2 and complex 3. Then it almost all it is convert into the cytochrome B. Then the cytochrome molecules, it is in the cytochrome C, again then cytochrome C. Okay, it is interlinkations of the 2 moles of the cytochromes. Then again of it utilized of the cytochrome A. Okay, then the cytochrome A is present in the complex number 4. So first complex it has only ubiquinol and FAD. Okay, then the second complex it is used to the succinate enzymes and that is the fumarate enzymes. Then almost it has then the cytochrome B, cytochrome C. These are completely it has in the complex number 3rd. Then 1 and 3rd. Then most it 3rd number of the complex, it is convert of the complex number 4. Then the complex number 4 it is utilized the 2 molecules of the proton, 2H plus. Okay, 2H plus, then 4H plus 8 and 2H plus 10. Then it gives to complicated to the then cytochrome A. Then again it gives to the cytochrome A. Then this most of involved in the 1 mole of the H2O. Then the water molecule is completely split out. Then half molecule of oxygen, at the same time 2 molecules of H plus ions. Then it convert into the ADP plus I, inorganic phosphates. Then almost all it convert into the ADP plus inorganic phosphate gives to the ATP by the presence of the F1 fumarase. Then it almost all of it has in the complex 5th. So here complex 1 to 3rd with then the involve of the cytochromes. Then complex 4 and complex 5 it also involved in the cytochrome A. Okay, then 1 to 4 mostly it has utilized the ubiquinons and cytochrome C. Then complex 4 and 5th mostly utilized cytochrome A and F. So most of this one, that is the AAB. Then mostly it has in the cytochromes almost all and complete step by step it has utilized of the electron transport. most of the electron transport, the step electron formation, then transform to the cytokinins. Then C, it has mostly reducing it. Then cytochromes is reducing, then the move of in the complexes. Then oxidations of the cytochrome, most it has in the mitochondrial citrate. Then that is the completions of in the mitochondrial citrate. Then the mitochondrial matrix is also involving in the then the mitochondrial matrix. Here often the matrix. Then the most of inner membrane space. Inner membrane space. Then the citrates, it used the citrates. Then this one is the outer membrane. Outer membrane. So almost all often the mitochondrial matrix, it mostly utilized of then the matrix. Mostly it has inner and outer membrane of the layers. Then the matrix mostly it has in the citrate. The type of the citrate with complications of the molds of ubiquinon, plasto ubiquinon. Then the plasto ubiquinon and the formations of then it has in the H plus form. Then mitochondrial matrix, it complete it has in the 2. Then the most of it has out of then the 4H molecules. Then 4H plus 4H plus, then it conversion of the Krebs cycle, then complete the Krebs cycle, it almost 4 plus 2, it is the intermembrane of the mitochondrial matrix. Then the 4 plus, then the intermembrane of the mitochondrial matrix. So then almost all 10 of then the mitochondrial matrices. So here mostly then the utilizations of the ubiquinons, then the ubiquinons. Then whenever it has into the complex of the 1, then the formations of then the ubiquinon, then it is conversion of the 2 to in the way of then complete then the B and C complexes. Then involve into the complete 6, 1, 2, 3, 4, 5, 6 of then the cytochrome 6 complexes. That is a cytochrome C and cytochrome A complex. So then cytochrome complexes. Then most of cytochrome complexes is involved into the then complex 3, the cytochrome complex C. So here the electron NADH complete. Then moreover the are 2 moles of then the glycolysis cycles. Then it transfer into the 2 electrons. Then directly of it transfer into the 2 electrons. These 2 electrons going to the ubiquinons. Okay. Then the ubiquinon. Then the ubiquinon completely most of then the formation that it has the step by step, then mostly then the electron transport system. It mostly then the summary of then the oxidation and phosphorylation, and then almost of then the that is the complete that transpiration, that is the F2, that means parties of participations of then the split out of the hydrogen molecules. Then the hydrogen molecules split out of then the utilize of the ADP plus inorganic phosphates, then conversion into the complete ATP. So here only then the almost among that is the overall reaction, we can use only one of then the ADP. So here one ATP only utilized in the one. Then one ATP only used in the electron transport system. So Then this electron transport system is also, it can be utilized of the 1 mole of then it has in the NAD also. Then the 1 mole of NADH is also 2 moles of the ATP. 1 NADH plus it is the 2 moles of the ATP. So 2 1 then 2 moles of the ATP. So here is the complete 3 moles of the ATPs. Then complete 3 moles of the ATPs. Then ATP, then here it is also 1, 2 plus 3 moles of the ATPs is produced. Then the electron transport system is almost all of the 3 moles of the ATPs are produced. So then it has almost often the formation that is completed then molecule of the H plus ions, then the mitochondrial matrix, then H plus ions move from the define of it complete matrices. Then complete matrices it often the ATP molecules. Then the almost all of then the convey or conversions of then the matrix it is due to the synthesis of the translocations of NADH molecule by the translations of the molecules. Then its complex of 2. Then complex of 2 it is completely 4 plus 2 molecules. Then the 2 complexes is involved into the 4 plus 2 molecules. Then it has most of the formations of the electrons, that is the formed to the 2 electrons is formed. Then the directly it has in the quinone, plastoquinone, then 3 plus it has moved to then the complete moving the down, it is the potential gradients. Then the 1 NADH it complete added to the H plus, then it is conversions of then the 2 FeNH2 plus, then the equations of completely it has in the 3 moles of the ATPs. Then the 3 of then the ATPs is 2 ATPs is molecules. Then the summary of phosphorylation is the FeNH2 and NADH is completely follows the NADH ions. Then the pyruvic dehydrogenase it has to the define of the electron transport system. Then it has most givens to the define of the electrons. Then the cytochrome of the copper containing then the proteins, this complex of transfer into the reduce of the cytochrome C. Then it consists of 2 major groups of the, that is the F1 head piece of and that is the participations of then the productions it has in the mitochondrial matrix. It complete mitochondrial matrix is involved the site of the convene. Then the converting the ADP it completely pulling off then conversion of the ATPs. Then here the step the gateway of the electron steps, the electrons forms from the each formation of FMN. Then the phosphate groups of then the oxidation of the NAD plus in process of complex 1 and process of complex H plus matrix of their inner membrane of the mitochondrial space. Then the ubiquinone is completely fixed. Then most of freely in the membrane, that most it has in the form of the mobilizations of the acceptors. Then the quinone matrix is reduced to the ubiquinone. Then the moves of the complex 3 has electron to cytochrome B and the release of 2 H plus ions. Then the complex 3 and complex 4. Moreover of the every 2 electrons it mentioned. Moreover of electrons every 2 electrons it passing off through the ubiquinone. Then cycle of a complex that has the complex 3, the transpirations of 4H plus ions in the matrix into the through of intermembrane spaces. Then the electron from complex third, then the transfer to the cytochrome. Then cytochrome C is completely reducing it has in the cytochrome C complex. Then otherwise it has in the oxygen is transformation to H plus ions. Then the matrix of the oxygen transformation in H plus ions that split out of the half molecules of the oxygen molecules. Then the split out of oxygen molecules and 2 H plus ions, it gives to the hydrogen molecule. Then it mostly in the NADH, it complete glycolysis transfer to the electrons to electrons directly in the ubiquinol. So transfer of electrons and NADP is given to electron transport. So the synthesis of then the ATP in respiration in also associated with the consumptions of then the cytochromes. The electron transfer from the NADH or FADH2. Then the oxygen through the complete electron transport system, it has result is a gradient of then the result the mitochondrial membrane. In inner membrane, it completely protons of then the matrix. Then almost all proton matrix. It is the inner membrane is also known as proton membrane. Then the it completely H plus ions. Then mitochondrial matrix, when the H plus ions they moves down to the outer kind of the membrane. Then it gradiently energy is the rotations of the F1 particle. Sum of amount of the energy and the rotating of F1 particles in combining ADP and phosphorus inorganic phosphates. Then most of it has leading the formations of ATP, then chloroplast. Again of the 3 molecules of 3H plus, it completely down of the potential energy. Then gradient of sufficient from conversion of the ATP molecules. Then the summary or inorganic compounds of this one is the electron transport system. So then here the electron transport system most of the utilized in the mostly it has in the aerobic respirations. Then most it has in the mitochondrial powerhouses of the mitochondrial membrane aerobic respiration. Then the aerobic respiration is completely complexes of then the 5 stages of the complexes involved, and overall among of the 3 ATPs are also involved in this type of the stage. So this one is the respirations, that is the electron transport system in the living, that is the aerobic respiration electron transport system. Almost all of this is the number of it is involving of the inner layer and outer layer and the matrix of the mitochondrial membrane. So this is the transport of the electron system. So the transport of the electron system use of the 5 stages. So the final of the 3 ATPs are produced. So this is the explanation about the electron transport system. So thank you everyone.